Hello and welcome to Service Meshes. So far we actually come quite far by creating a production ready cluster, re-architecting our application into multiple microservices. We provided asynchronous communication between. We also provided our own authentication and authorization mechanism, and we've kind of functionally decomposed based on different domains. What we are going to talk about in next few videos is basically the non-functionals or the infrastructure services, such as we wanted to, after creating all these different microservices, we wanted to centralize how do we monitor those services. We wanted to centralize how do we find bugs, how do we debug those services, how do we actually understand the communication between those services, how do we actually get all those different telemetry data, which is basically provided by our cluster or our services as part of logs or as part of metrics and things like that. We also wanted to, kind of building some kind of a functionality where we can actually manage traffic between those services. We can actually deploy a new version of services without impacting current users or current consumers. We can do such as canary releases, right, where we can actually introduce new features to a certain group of user and not impacting others users, right? How do we build security in between those services? So the security which we build is more like a functional security where we are authenticating users, but because now our service is running in multiple different pods, which is on multiple different nodes, and tomorrow when we extend to multiple clusters also, it will be a different reasons where our payload will be running. So how do we actually secure communication between those services? How do we create different kind of policies, like for example, how do we introduce rate limits? How do we actually make sure that we can block or we can cap certain consumers to actually give all the functionality or all the resources to everybody? So those kind of things, right? And all those different things, which is basically the traffic management, security and telemetry and all those, we don't want to actually build those things inside our services. Our services should be agnostic to all those different decisions we are making around the operations of those services, or around the non-functional of those services, or around the infrastructure around those services. We don't want to do any kind of changes or any kind of any kind of dependency, build any kind of dependency on our services, because we wanted to build services which is agnostic to those decisions, which can actually run in any kind of environment, whether it's a development environment, testing environment, or different kind of production environment. Even we can switch cloud providers whenever we want, and our services should not be dependent on those services to actually make those choices simple. And that is where this whole concept of service meshes comes into the picture. Now, of course, I'm not going to go through in detail about what this service mesh and how this works, but what I will actually quickly go through is the actual fundamental around the service meshes, right? So service meshes is actually nothing but a very tiny bit of services, or tiny bit of containers, which is kind of build along with your actual functional service container. So they are a small container which is injected while we actually deploying our applications, and those containers basically provides information which we need to produce different telemetric information around the logs, or around the metrics, around distributed tracing, and all those different kind of things, around security, around different dynamic routing, and all those kind of different things, right? And those containers are actually managed by a centralized process which we call a service mesh, which is basically Istio in our case. So we are following Istio, which is basically initially developed by Google, and it's actually used the very core container. It's called um, Sidecar, which is basically came from a different organization. So how this whole thing works? So if you see the diagram here, we are referring service A and service B, our functional services, and the proxy they are talking about, these are the tiny container which is actually injected when we build or deploying our service A, if we have this Istio enabled in our cluster. And what this does is actually those proxies communicate to the centralized which we called it control plane, which where we actually gather all the information and then connect to different products to produce that information to do telemetric and traffic management and things like that. So just quickly go through our cluster and show you how this looks like. So basically Istio install all the components, the central components in namespace called Istio system. And if you just see the resources, basically services and pods, you can see there are few services which is created, which actually most of them are related to telemetry. There are ingress gateway, there are pilot, and there are other agents which basically monitor those sidecars which is injected in our functional services, and there are some pods as well. So basically what happened is, if we go and see our namespace, you can see that we have all these containers, right? We have all the functional services, stock service, shipment service, or service, and things like that. But the only difference here is, instead of actually having one container in each pod, we now have two container in each pod, which basically saying that we also running a Istio proxy or a sidecar container along with our each of our services, right? So that is where it actually going to collect all the data when we actually execute our services and produce different things. So in this video, I'm only going to talk about the telemetry, which is basically talking about metrics and logs and other information to really understand what is happening in our services. And then in subsequent videos, we will be going through traffic management and security and other things. So basically, as I said, I'm not gonna go to the details of configuring Istio. It is very simple. It's everything you can actually get on this website, which is istio.io. The installation is absolutely simple. There are few deployment files which you need to actually deploy using kubectl, and that will get you going. And then there are specific things mentioned in every section of this particular documentation, so you can actually follow along. But I'm going to concentrate on based on the services which we have deployed. So let's talk about telemetry, and we are going to talk about two things in our telemetry. So actually three things in our telemetry. It's a overall understanding how our services and how our payloads and how our Kubernetes services are working, where how they are actually communicating to each other, what's how the data is actually flowing and things like that. And then we move on to more specific metrics, which is a kind of a time series based metrics to understand the response per second, request per second, latency, and all those kind of different things. And then we also going through and seeing the specific kind of metrics, which is basically the traceability. So traceability is basically one service is calling another service is calling other service, and we need to understand how much time each service is taking to complete the end-to-end call, and this that kind of things. That is bit a very kind of a specific functionality, so I will go through that in a bit. So let's start with the overall understanding about the infrastructure, payload, and services. Basically what happened is, Istio come up with few different tools, right? And one of the tools is Kali, which is basically the visualization kind of a tool which collects all the data through the sidecars and produce different kind of information which will help us to make different decisions. So okay, so before we actually go through Kali, I just wanted to tell you that we are also I'm also running a continuous kind of process to submit data to our services so that we can see some kind of logs. But it's basically what I'm doing is, if you see this diagram, I'm just so using API gateway, I'm actually taking the auth token from auth service, and then using this auth token, I'm actually first submitting the product to the stock service so that we have the product in our warehouse, and then using the product and auth service, I'm actually submitting multiple orders, which going through the shipment and then manually processing those shipment and then querying whether the status has been order status has become closed or not. So this is the simple process where we involve few services, and there are a lot of requests going on between those services so that we can see some activities on Kayali. So the first thing on Kayali is basically the landing page where you can see different namespaces, and we are interested in project logistics namespace. So if I click here, you can see all the applications currently deployed, which is basically these are the apps values we configured in our deployment, right? So we have auth, we have gateways, orders, query shipment, and things like that. But before going to the application, I wanted to show you the I think the most important thing in Kayali is basically the service graph. Now this service graph, of course, it looks quite complicated because we have so many different services and so many different products like database and Kafka and things like running in our cluster, which is getting this whole picture very complex. But we can actually dive into a specific component. But I would just wanted to show you that you have option to select different type of graphs, so you can actually see the workload graph, which is basically our actual pods. You can definitely see the service graph, which is talking about which service is talking to which service. They don't really talk about what is the underneath payload running, but only the services. Of course, you can set different type of communications between those services, and of course you can have multiple things going on here, like for example how many requests per seconds and things like that, because I'm continuously pushing data to those services, so you can see some activities. But if I actually zoom in here, it is basically very kind of a simple communication. Of course, we have multiple services. That's the reason it looks complicated. But if you see this gateway service, it is actually communicating to our order service, our query service, stock service, shipment service, and things like that, right? And it's the data is currently going on. Of course, the stock service you don't see much activity because I just submitted one product and then continuously using that product to submit orders, so you don't have much communication here. And also you can see these logs which actually showing us what kind of security happening in between those services, which we'll go through in different video where we talk about the security specifically. So yeah, you can see that, and there are different, you can actually get into those services itself. So for example, if you right click and if you go to the show detail, you can see um, how those request volumes and duration is happening, and what are the percentile and average and things like that. So those this is quite interesting to really see how the services are performing. There is another thing in the overview which we'll go through in different video where we're talking about the traffic management, but you can actually set things how many requests you want this particular version of service should actually get versus the other version. So when you wanted to release new services, you can actually modify or balance the number of requests between those services to actually test that particular version of service. So that's Keali. The other thing, and of course, there are a lot of other things around the workload and services and applications, right? So the next thing I just wanted to go through is Grafana, which is basically again, it is again based on the data which we are collecting from the Istio sidecar, but this is more like a time series data. So this is basically producing different graphs, different information around how we are how our services are working in terms of getting data, processing data and things like that. So I think most important. So if you actually go to so there are inbuilt dashboards. We are more interested in the service dashboard, where we can actually select multi different services. So right now, for example, I've just selected query service, but for example, if you go to order service, right? And in last 5 minutes, I wanted to see how our services are, the order service is performing. So client request versus server request, how many client request, duration, milliseconds currently. So under 100 milliseconds, we are actually getting the request. Server processing is also on almost under 100 milliseconds. Incoming request by source. So there are a lot of information around, how the service is performing. And the key thing here is whether we talks about Grafana or we talks about Keali, we haven't made any single line of change in our services. Our services don't even see how their data is actually presented, or who's actually collecting that data. And that's the beauty of Istio, because you actually making your service agnostic to all these different tools. Tomorrow we can replace all these tools with a different set of telemetrics tool, which can actually produce different kind of information what your organization wants without actually touching your services. The other thing is that your service can now run in any environment, because there's no direct dependency. The whole sidecar pattern or the whole STO proxy pattern is actually hiding the complexity or the dependency with these product between services. So that's the beauty of STO. Um, I mean, these are the things I just wanted to go through at a high level, STO. And the other thing I wanted to actually also touch upon is basically the service tracing, right? So this is where we wanted to show how the communication between multiple services is happening. Now, unfortunately or fortunately, our services are mostly asynchronous, right? So they don't really have the dependency on each other. They basically submit the publish the data, and then some other services who are interested consume that data from Kafka and processes. So we don't really see that kind of nested communication here. But what I wanted to actually show here is that, for example, if the gateway is if the gateway is actually calling that order service and posting that order, you can see that there are two kind of nested communication happening, and it's basically showing how much time the overall gateway process is taking and how much time is its particular order process is taking. But if you have more nested services, then you can see underneath order you might have some kind of a validation service or some kind of a configuration service, something which is basically now. But there are things which we need to actually do to produce these kind of tracing, because tracing basically need a data, a kind of a constant data, passed through in different hops of the services, so that those kind of tools can actually interrelate those data. So we need, for example, in case of HTTP, we need to pass HTTP certain HTTP headers between those services, so that those services, those service communication will be connected. um, so yeah, there are a few things we need to do to make this tracing thing working. But apart from that, to be honest, this whole Grafana, which produce a lot of information, Keali, which is a kind of, I really liked it because it's kind of, for me, it's kind of a place where I can actually get the initial workings around that. So if you just seeing this yellow thing or the orange thing, basically if you click on the legend, you can see the orange is basically the, if there are some errors, it basically going to show that there are errors happening between the query service. So there might be services degraded, or there might be a HTTP errors or something like that, which you can actually see. So I can see there is a error called 400 error, which is basically showing like 2.6% communications, basically getting 400 error. So those are the things basically give you an initial understanding that what's happening between those different services, so that you can then go detail and either gets into the Grafana to see, or to get into the log. So for example, if you go to workload, and if you click on, let's say, query service, And if you go to the logs, you can actually see the exist what's happening in the service in the container right now. So those are the things which makes debugging quite simple. So that's it for the telemetry. The next video we are gonna jump into traffic management, more kind of a dynamically releasing new versions in production, and then capping those version to a certain user or a specific request, so that it won't really impact the overall user community or consumer community. So I will see you there then. Thank you very much.